Don't see myself.
Everybody wants more.
Okay, sir.
Today we want to look at sample size and design effect, or design effect and sample size. We want to quickly look at, because since we started our series on sample size, many people have been raising question of design effect and how it affects sample size. So today we are going to look, being the last day of the series on sample size, we'll quickly look at what design effect means and the causes, and how we adjust for it or correct for it while calculating or estimating our sample size. Most of the time we get involved in survey, and during survey we do develop. So we try to cover a large geographical area. And you know that survey is very, very expensive. And in order to still cover the large area, I'll still be able to bring something out within the available resources. So there are some compromise. Well, many people may not know that it's compromise, but the people that are scientific in thinking will know that they are compromise. We reach because by going for cluster sampling, the origin of cluster sampling is in industry. It was a method of sampling in industry where, after production, the products are packaged in a certain amount. Maybe the particular product is packaged 40, 40, 40 in one pack or whatever. So sometimes in trying to sample for defect, you just pick at random, you pick one pack. When you pick the pack, you dismantle everything and examine everything inside the pack. And that is where, because everything is a cluster, each unit you have to observe. Once you pick the pack, of course you have access to every unit to observe them for defect. And sometimes ago, WHO give the recommendation that this clustering can actually be used. They call it area sampling. Where you can just sample a particular geographical area, pick a particular village or hamlet, and now examine or collect data from all the elements. If you are studying children, or the children under 5, if you are studying pregnant women, or if you are studying women or reproductive, whatever population you are studying, you carry out your observation on all the people in that cluster. So you will notice that if in doing that, people in a particular village or in a particular house or in a particular hamlet or area may likely be similar in certain characteristics than other people. So for example, if you sample, we use it a lot in all these polio eradication program, many health program, we use the cluster sampling. But when you look at some variables like socioeconomic status, if you go to a village and just sample a particular village, they are likely to be similar than some of these indices you are measuring. And in that case, there is a correlation. We call it intra-class correlation. Let's go on. You get to understand the reason clustering actually affects the effectiveness or the estimate, the parameter you are trying to estimate. Clustering sampling is commonly used rather than simple random sampling as a means of saving money rather, when the population is spread out and the researcher cannot sample from everywhere. However, respondents in the same cluster are likely to be somewhat similar to one another, just like what I said. in many respects. Though there are some, it varies. There are some characteristics that may not be similar. Like now, something like if you are measuring something like height, weight, you may not see similarity. But if you are, you may not see correlation among the member of a cluster. But if you are measuring something like income, maybe even sometimes perception to certain things. So the perception and belief, perception may be driven by belief, especially if all of them have the same beliefs towards certain things. So in that situation in the cluster, if you maybe a cluster contain about 20 people, you think your observation is from 20, but actually it may not be more than 2 because there's right correlation. It's the same thing they are saying, the same, almost the same response you get from all of them. And the same thing applies. In some situation when somebody you are studying, you want to study something, the facility, like one of our colleagues study availability or study preeclampsia in facility in a particular place, and in a situation where you sample, you question, you administer questionnaire to health worker in the same facility. If they are 10 health worker, you are asking for availability of this. What is this? What is that? Is this one available? Of course, then the same facility, the responses are going to be similar. But there are some responses that may not be affected by clustering. Those ones are individual. Well, you can, like network, I want to know their perception, what they perceive about something. It may not be affected by, but there are some things, how things are done in your place of work, how the place of work affects your study in your work, the way you practice, the way you manage a particular problem. There's going to be clustering effect because if you sample many people from a facility, they will likely, because it's the same factor that affect them. So there will be clustering effect. As a result, in the cluster sample, selecting an additional member from the same cluster had less new information than with completely independent selection, just like what I just said. So if you know, after you have administered to questionnaire to one person in the facility, you select another person. If they are patient, that is different. But if you are talking of health workers, you may not get additional information. So in a single cell cluster sample, the sample is not as varied as it will be in random sample, so that the effective sample is reduced. So you may say you have 3,000, but the number that is effective may not be more than 1,000 or less than that because of that clustering effect. So geographical clustering is generally used to make study easier or cheaper to perform. As I've said, the effect on the sample size depends on the number of clusters and the variance between within the cluster. So the effect of clustering on the sample now depends on the sample size, depends on the number of cluster, cluster, then even the number in each cluster also, the cluster size, because average cluster size. So if you, I don't know if somebody, okay, if you have your question, you can just write your question, post your question, start posting your question, so that when we finish, we can just quickly attend to the question. So the effect depends on the size of the cluster. Also, the variance between and within the cluster. So variance just means the attribute you are measuring, do they vary much? Do they correlate much? That's why we're going to talk about inter-class correlation. In practice, this is determined from previous study and expressed as a constant called design effect. So the sample size for simple random sample are multiplied by the design effect to obtain the sample size for the cluster. You're going to get to know it very well, understand it better. Components of this design effect. The design effect is actually the variance you observe in a cluster sample compared with what you will have observed if you have used simple random sampling. So the comparison is this design effect. So it depends on intra-class correlation and cluster sample size. That is, each of the cluster, what is the size of each of the cluster, and the intra-class when we talk about intra-class correlation, we talk about the correlation of intra-class correlation of the statistic of interest you are measuring. So the formula, you can just see the, well, you cannot say the illustration. Design effect is 1 plus delta into n minus 1. You know, if you get to see this formula somewhere, it's the same, but they may use something. Instead of n, they can use m. Instead of delta, I can use rho. So it doesn't really matter, but you discover that it's the same thing. So what is important in the formula is definition, explanation of those items in the formula. So DEFF is the design effect. The N is the average size of the cluster size. You know, you have many clusters, but what is the average size? Now, the data is intra-class correlation. Is it data or row? Yes, data. Intra-class correlation for the statistic in question. And the inter-class correlation, if there's no correlation, is 0. You know that correlation is between 0 and 1. So if it is low, it is considered to be low. Inter-class correlation is considered to be low when it is less than 0.10. Then medium when it is 0.11 to 0.19. So it's said to be high. Inter-class correlation is said to be high when it is greater than or equal to 2. Is 0. Sorry, it's not 2, it's 0.2. Rather, it's 0.2. Now, the design effect is the loss of effectiveness by use of cluster sampling instead of simple random sampling. So the loss of effectiveness by the fact that you use, so effectiveness mean that the degree to which you are able to estimate the parameter of interest. So you are not likely to get the right estimate if there's design effect. The loss of the degree to which you will have gotten the right estimate is the design effect. It is basically the ratio of the actual variance under the sampling method actually used to the variance computed under the assumption of simple random sampling. So what it means is that you are comparing what you will have gotten if you have used simple random sampling, where you sample each person. So whoever comes is a function of chance occurrence, not that you just go to one place and now gather everybody. Because in this in cluster sampling, it is cluster you sample. Once you sample the cluster, every eligible element in the cluster is examined, is part of the study. So it's a drawback. But unlike simple random sampling, where you just know individual, each element is from different places. So the clustering effect is not there. For example, if the design effect is 3, it means that the sample variance is 3 times bigger than it would be if the survey was based on the same samples that they selected randomly. So an alternative interpretation is that only 1/3 as many sample cases will be needed to measure the given statistic if a simple random sampling was used instead of cluster sampling within its design effect of 3. So what he's saying is that if the design effect is 3, it means that in that cluster sampling, you need 3 times sample size than it would have been if you use simple random sampling. So you're going to see that how do we adjust? When we adjust, you see that adjustment for it means that you are going to increase the sample size for you to get the same effect you will have gotten if you use simple random sampling. So in cluster sampling, the implication is that you have to increase the sample size.
No.
Then the alternative interpretation is that only 1/3. Okay, I think I've said that one. Now, the components still continue. Design effect, you can see now it increases as cluster size increases, or the cluster sizes increase. Intra-class correlation increases. So those two things that determine the design effect are the cluster size. The more the cluster size, the more the design effect. The more the people that give you similar thing, you are not getting information. They keep on giving you the same thing, and you have them. So we say that the cluster size is 30. All of them, almost maybe what you get is like you have gotten from only 5 people. The intra-class correlation represents the likelihood that 2 elements in the same cluster have the same value for a given statistic, relative to 2 elements chosen completely at random in population. What this one just means is that correlation. When you say intra-class correlation, it is correlation, but the way it is measured is you measure, okay, the correlation within divided by the correlation outside. That is, you try to know how close the value, how close or related the value you get from different people in that cluster, compare with what you will have gotten outside if you have, you sample people outside this cluster. So the value, for example, if the correlation is 0.05, correlation is between 0 to 1. 1 means 100%. So if it's 0.05, it means that the element in the cluster are about 5% more likely to have similar value than if 2 elements were chosen at random in the survey. So the smaller the value, the better the overall reliability of the sample estimate will be. So if the intra-class correlation is very small, it will give you smaller design effect. But if the higher the intra-class correlation, the more the design effect. So now, we want to quickly see how do we make the adjustment for this design effect in sample size estimation. It's very simple. I will not bother us much. If you remember, we have talked much about sample size for descriptive study. So let's say one survey, is if you say single survey, that is only one group, is sample size for descriptive study. Look at, if you remember, Z alpha PQ over D square. That's what you see here. The Z alpha, if it is 0.05 level of significant, that is 95% confidence level, 2T. The Z is 1.96. That's what you are seeing here. And the D, the denominator, if you remember, is the level of precision or maximum error of estimate. You usually choose 5%. You don't want to deviate from the population, the parameter you want to estimate by more than 5%. You usually choose 5% as a constant. So the only thing you get to know from the population, from previous study, is the P, prevalence of the attribute, estimate prevalence. So the estimate prevalence is there, and 1 minus P is the Q, the formula we showed you before. So if you look at it, this is formula for the study. All you need to do, if you are calculating your design effect to be 2, you just say multiply by, you just put 2 there. Can you see? N is design effect times, that's all. It's very straightforward. Once you know the design effect, you multiply, you use to multiply your sample size. So actually, you may even calculate your sample size, and once you calculate your design effect, all you need to do is the inter-class correlation and the sample size, the size of the cluster, which we have shown before in the previous formula. I showed the design effect. Once you know the design effect, it will give you just, so it makes sense. It ranges from 1 to 2, sometimes it can be up to 3 on real occasion. So you just multiply your sample size you have calculated by the design effect. If you are comparing two surveys, estimated 2 surveys, You just estimate it and multiply. So if this one just, you can just say this one more like a PCNA, just to put the sign effect, multiply by the sample size. So you can as well calculate your sample size first and know the design effect and just multiply. So that if your design is 1.5, if you have calculated your sample size to be 200, that shows that your samples you have to increase to 300. You multiply 200 by 1.5, give you 300. Just so, if it is sign effect is 2, if you have calculated your sample size to be 200, that shows that it's going to be 400 for you to be able to get the same estimate. So now, stages now in calculating your sample size. First of all, calculate sample size estimation. You estimate your sample size with your, depending on which study design, which variable, what is the variable of interest? I mean, the type of outcome variable. So it will determine how you calculate your sample size. Then when you talk about study design, is it one group or 2 group, or the 2 group are the independent group or peer group? Those are, we have already ironed out all these issues about sample size before. So that one will determine what formula, how do you calculate your sample size. Then you now factor in your design effect. After that, before you now come in the issue of contingency addition, which is giving room for non-respond or attrition. You know, we talked about it. Yeah. Was it last time? If your attrition rate is 10%, you don't just add the 10%. You divide your samples that you have calculated by 1 minus that 10%, or 100 minus 10%. So, like for example, now if attrition rate is 10% and you have calculated your risk to be 300 over, you will not just add 30 with 10%, no. 300 over 0.9, 1 minus 0.1. You see, 1 minus 0.1. 0.1 is 10%. 1 is 100%. So 1 minus 0.1 means 90%, which is 0.9. So you now, if you divide your 300 by 0.9, it will give you something like 333. Rather than adding 30. If you add 30, it will give you 330. You calculate 10% of 330 is 33. Remove 33 from 330. You know that it give you is not 300 that remain, whereas your minimum sample size was 300. So 300 is not 300 that remain now. If you now remain 297, so to speak. So you see now, it has gone below. But if you divide it by 0.9, it will give you amount 333. So if you now remove that 10% from it, you see have your effective sample size there. So that is just the explanation. I don't know if there's any question. Let's entertain question now. Let's entertain. Okay, somebody shouted. Okay, somebody say I should mute. Who might are not mute? Okay, but I was not hearing. Is it still making noise? Is it still making noise? Because I can't see anybody with a mute microphone. So any question? Please complete. Somebody said. Any question?
Yes, sir. Please, I have a question, sir.
Okay, go on.
Thank you very much, sir, for this session. It was really a very rich one. Please, sir, I have 2 questions. The first was that I did not understand that 100. There was a place where you have 5%, 100%. I didn't really get that. I think you can explain that particular slide in. I think the title of the slide was Component Design Effect. Then my second question is, the higher the cluster, isn't it the less the intra-correlation, the intra-class correlation, that's the more the cluster?
Well, it cannot be, because the issue there, if you look at what let me just show the slide. Because this question you're asking now, there's no need to ask it. You see the reason I say that?
Okay.
You see. I think this is where you are talking of, right? Is it here? Okay, if it is not this place. If you look at it, the intra-class correlation and cluster size, there are two different things here affecting the sign effect, and both of them as they increase, the sign effect increase. You get the picture. So the issue there is that whether, well, it depends whether maybe as the size, sample size, the cluster size increases, whether the intra-class correlation will increase. I don't think so. It has nothing to do with the. No, would decrease. Okay, it has nothing to do with it. Has to do with the dynamics of the relationship between or among the people in each cluster. What they were exposed to before. But the only thing is that if inter-class correlation is constant, let's say you make it constant, as the sample, the cluster increases, the sign effect will increase also. Because what really happens is that if all of us we have the same, we have the same belief, or maybe people are in the same cluster, when it comes to socioeconomic status, they are low socioeconomic status. Okay. And they are exposed to the same factor. If you are not asking question, maybe that's something you are measuring. You should be measuring the same thing because all of them they are the same. So you take it. Oh, so you mean each that is within the cluster? I thought we were talking about the number of clusters. Does it the number of clusters increase? No, it's not the number of clusters. This, if you look, I say average size, cluster sample sizes. Cluster sample size. It's not the number of clusters. Oh, I understand. Okay, yes, the intra-class correlation definitely increases as the each cluster. That's each cluster sample size. I thought you meant the number of clusters. If there is anything intra-class correlation, the effect will be marked because all of them. The more you take more people, the more you're just wasting your time. Okay, I now understand it now. Okay, I didn't get it. I thought you meant it in terms of that is the number of cluster. No, if you say if you not per se the sample in each cluster. Can you get? No, yes, because the cluster can even be different because we have different sizes. But we are talking of averagely how big are those clusters. So the bigger, the more the design effect. Okay. Because the people there. The more, because you are going to, yes, of course, the more the intra-class correlation. Put everybody into your study. You just be jam packing your study with people that will give you, they are telling you the same thing, even though they are 30 in number. That are similar anyways. There are similarities. So they are not giving you any new thing. Okay. Yeah. I don't know where you say that you say 100. Then please say that 100%. I didn't get that one. There was something you were saying about 5%. Thank you, sir. Okay, that's great. Yes, I think it's this one. No.
Yes, there is.
The next one.
There is.
So I didn't get. Hello, sir.
Okay.
Okay, hold on. I will go back.
You haven't answered my second question, sir.
Okay, I'm coming, Dr. Ikobo, sir.
Okay. Sorry.
The second question talk about what? If I remember.
The 5%. Yes, this no. It comes after that the formula for design effect. The next slide after the formula for design effect. Okay, I understand. Oh no, I'm talking of if the intra-class correlation is 0.05. You know, if intra-class correlation. That's one. Yes, the next slide, sir. Yes. I had this one. I didn't understand it. What does that mean? If the intra-class correlation is 0.05, it means that 5%, 0.05 is to express it as percentage is 5%. It's 5%. When you multiply the 0.05 by 100, it's 5%. It means that the element in the cluster are about 5% more likely to have the same value than if the two elements were chosen at random. If you're talking of inter-class correlation, the bigger the inter-class correlation, if the inter-class correlation I understand is 0.2, okay, the smaller the value. They are 20% more likely to have similar reliability of the sample. Okay, I now understand. Yes, it makes sense. Thank you, sir. Okay, thank you. Okay, sir. Okay. Answer your question, sir. Okay, small value. Yes, thank you.
Prior to this time, when we are adding additional listing for attrition, let's say, we normally add 10%, but or 20%, depending on what you want. But from this lecture, you are saying that we should not add that it's 1 minus, for example, if it is 10%, you want to, it's supposed to be 1 minus 0.1. That place is not clear.
Okay, it's not clear. Okay, I think okay, no problem, sir.
It's not
if you remember, I demonstrated it. Let me just do that now. I demonstrated if your sample size is, you calculate your sample size to be 300. N is 300. And you just add 10%. 10% of 300 will be 330. Right? So if you add it, it will be
yes.
330. Now, yes. So what is this 10%? If by the time this is the one you are now using as your sample size, if the attrition actually is up to that 10%, it now happen, or the non-response is up to 10%. Up to 10% now occur. 10% of 330 will be 33, right?
Yes.
10% will be 33. You agree with me, sir?
I agree.
Yeah, 10%. If you remove 33 from 330 now, what does it give you?
330 minus 33.
Yeah, if you remove it from here, this one will be 2. It will go to give you 297.
Yes, 297.
Right? It give you 297. So by the time you added 10%, but when the 10% happen, your sample size has gone below the minimum sample size. So what you should do is to say the new sample size would be 300 over 1 minus attrition rate or non-response rate. You can call it attrition or non-response rate. So if your non-response rate is 10%, so you go to 3 over 0.9. That is 1 minus 0.1.
Okay.
Which will give you 300. So somebody should just do that now. All over 0.9. So it will give you something like maybe 333. So if you now calculate 10% of this and remove it, when you remove it, it just give you that 300. Is it clear, sir?
Why are you removing it again?
No, what I'm saying, if the essence of the non-response rate you calculated is in case it happen. So if you calculated it now, the final you now use is 333. So let's imagine that in the process of carrying out your study, 10% attrition happen. So calculate the 10% and remove it from 333. You will still have that your 300. It will not go below your minimum sample size. Does it make? Is it clear, sir?
It's clear. It's clear.
It's clear now.
It's clear.
Yeah,
clear,
that is what. So it's not but just by adding, many people just add 10%. But it may still work if not up to that, your predicted attrition rate may not happen up to that. But in case, if that up to that percentage happen attrition, your sample size is going to go below the minimum. And that is why the best way to do it, or the right way to do it, is to use the formula. That sample size all over the 1 minus the attrition or non-response rate. When you calculate, it will now give you the effective one. Okay, I think it's very clear.
It's clear.
Yeah. Any other question? Any other question? So that's what is very clear.
Yeah, excuse me.
Yes, go on, sir.
Yeah, in reported studies, I'm just wondering how one will get the value of delta and the n so that you can take care of that design effect. But what you will see in the literature will be prevalence or rate or something, but how to get the values to substitute for that delta and the N is an issue.
Yes, if you remember, sir, when we started talking about sample size calculation, we talk about literature review is just one of the sources of all those things, apart from the fact that there are some things that are constant, the Z, the power are constant, but those prevalence you're even talking of, you discover that sometimes you may not even get there from study. And that is why you have to do pilot study. Sometimes you may have to do pilot study, you know, or yes, you just take some little sample. So you can go and, if you cannot get the interclass correlation for the attribute you are measuring, among those, you can actually take some sample and measure it and calculate the interclass correlation.
Okay.
Is it clear, sir?
Yes.
So you can do that as a, even sometimes if you don't even do pilot study, you can do during the time when you are doing pre-test. No, say they are pre-testing the instrument. You can take the measurement and just go and find out. So those are the ways you do that. Sometimes also you may not see, you may get it in a study that is not published. You have a lot of unpublished study in the library of an institution. You may get, if you cannot get, you can do something like pilot, just collect few samples from the population you want to study. You know, most of the time they say when you want to do pre-test, don't go and use the population. But then when you are talking of pilot study now, this one, because it has to be the same population, to really know the interclass correlation of the attribute you want to measure. So that once you calculate it, you can now factor it into the sample size. Any other one?
Finally, so design effect can only, we can only talk of it when the sampling is clustered.
Yes.
We
Yes.
can't
But
talk
some
of
people,
design effect in random sampling.
Yes, well, it may not actually be only clustering, but there is more problem with clustering. In a situation where you cannot do probability sampling, yes, I mean, but you know, you may even do that if you are studying all those drug addicts where you usually use snowball. You know, you usually use snowball. But the problem with that type of thing is that you may even, by the time you can factor in the design effect, and at the end of the day, the sample size is high. Even those who are difficult to reach, you may not even be able to get up to that number. Because most of the time, the snowball method, people don't actually follow sample size. They may make an estimate, but people try to get as many as they can get because they difficult, because they are hard to reach people. They are difficult to reach people. So it's not only clustering. Anything that you may not to, people say simple random sampling. It's not actually simple, just probability sampling. Most of the time, simple random sampling, because sometimes the simple random, the stratified random sampling maybe even be better. It's better than simple random sampling in some situation. If the population you are studying occur in strata. For example, if you are studying university student and you want to, you know, what the attribute you want to measure cut across different levels, it will make sense to do proportional sampling or stratified sampling. Stratify and do proportional sampling. You know, if you just do simple random sampling, there is a probability. You know, you sample one set, one set more to the detriment of the other. So somehow, you know, for the fact you say probability of, if you say probability, because simple random sampling, all the elements have the same probability of being chosen. That's what it means. But in the real life, it doesn't work like that. Even though they have the same probability of being chosen, since there are something that divide them into cells, and you want those starter to appear, you know, to be equally represented. If you do simple random sampling, it will not work. All the strata will not be equally represented. So in that case, even proportional sampling will be better than the simple random sampling. So it's a situation where the the logic behind it is for you not to know, not to have an estimate that would differ from the right one, because you are sampling a group of people and you have not used simple random sampling. So there is a somehow all the people you are sampling, they are not representative of the whole entire universe of the people you want to study. Is there somebody want to ask another question?
Yes, sir. In fact, there was something you just said now that resonated with me. And I think I now understand why one of my supervisor said something. So, like how you're assessing, you use the students in a school where you cannot do random, you have to do proportionate. So, sometimes when you calculate your school size, for example, let's say you're trying to randomly select, let's say, 10 departments in a school. If you calculate your minimum sample size and you, let's say you now, and you also do loss to, that is attrition, you calculate for non-response, and you add, sometimes that sample size might be too small when you now do proportionate allocation along each of those different departments. So the number of I'm just trying to find out, is that the reason why they sometimes say increase your sample size so that you'll be able to carry out analysis in each?
You are not taking each the people you sample from each cluster or each level strata, each stratum separately, analyze them separately. How can the sample size be true? If your sample size is already large, just for you to get equal representative from different strata. So unless if you want to,
but the thing is that when
based on that based on the stratification, so it may not be too small.
No, because the stratification, they said, if that stratification is important, let's say they want to find out if, let's say, medical students, law students, and let's say different students now. So that difference is important. They want to start different. So and when you now,
of course, if you want to do analysis along each stratum, of course you have to increase your sample size. But the removing doing stratified sampling and proportionate sampling for each stratum is not because you want to do analysis. It's just for them to be equally represented. Because if they are equally represented, your estimate would be better.
Yes, sir. No, that's not my question. My question is, in terms of, they tell you to increase the sample size. Because if, for example, let's say the calculated sample size ends up being, let's say, like 400. Let's say it's 400 now. And if you do proportionate allocation, you know that if you split that 400 sample size, let's say across medical students, lawyers, and let's say engineers now, the sample size you might get might be, maybe you might get 100 in one, 200 in one, then maybe the other one might be 100, or if the sample size is 380 something. But what they are saying is that sample size in each one, let's say in medicine, that's, and when you do your proportionate, and let's say 100, it will be small to that. They always tell you to add, to increase your sample.
You need to increase your sample size if you want to do analysis based on strata by strata.
Right? Why, sir? Why is that important? Because I know, I understand it, but I want to understand. You know me, I like understanding details about that. Is
so if you want to,
thinking behind
number
it.
one, if you want to do analysis, especially when you want to look at factor responsible for something, if the sample size is very small, you won't be able to get the factor. It's going to be difficult because most of the time the computer, especially when you're even dealing with categorical variables, if you are trying to run logistic regression now, is categorical. Is iteration is just by repeating some step. Is by arrangement, more like permutation. Is arranging them using arrangement. So if it is very small, you won't be able to get it. Will not be possible. In fact, sometimes if the sample size is extremely small, if the attribute you are looking for is maybe only few, when you want to run the analysis, it will not run. The computer will just hang because you don't have enough. Especially if the attribute also is maybe it's only a few people that have the attribute. So If you increase the sample size, it will be easy for you to run the analysis.
Thank
So
you,
that is
sir.
why if you
So
want
this
to,
is now
you
where
want
my
to
last
analyze based
question
on
comes
status,
in.
that's why you increase. But otherwise, there's no point increasing it. The essence of the song is just for them to be equally represented. That's all.
Okay, so that my final question now comes: could it be that they are trying to avoid the cluster effect by increasing the sample size in each of those groups?
No, the cluster effect does not increase the sample size. We want to remove the cluster effect. It's not by increasing sample size. Well, it's not by increasing the sample size that
it's by increasing the clusters.
They actually doing. It's for
true.
you not to have all of them. If by mistake you go and sample only one group. Of course, if you sample only one group, few group, you don't put other group. Somehow, the cluster effect will be there. To be sincere with you, and the variability, what you expect from it may not be representative for all the university, all the different of the whole school. So actually, the issue of clustering, design effect, people have already known that they are doing clustering sampling because of cost. They've already made up their mind. So in doing that, they know that there's a price you pay for it. In order to minimize the effect of the price, they now increase the size, the sample size.
But since the sample size in a cluster doesn't really increases the intra-class correlation. So what's the point?
What is that? It's not the samples. You see, the cluster have their own size. The cluster size is different from sample size. If you now increase your sample size, that shows that you take more clusters. I don't know if you understand me. Because yes, you've already known the average size of the cluster. So if you now want to increase the total sample size, what it means that you take more clusters. Are we together?
Yes, sir. Yes, sir.
Taking more cluster is not increase. You cannot increase the size of the cluster itself because it's already there. Like now, if you are studying the population of each cluster is already there. It's not you that you are not increasing their population. It's already there. It's just for you to have an average number so that you know how it will affect. You will not have the average size of the cluster to really know the extent to which it will affect your study. So in that case, you now increase the number of you increase your sample size. If you increase your sample size, that should have more cluster will be involved.
Thank you, sir.
Welcome. Yes, any other one? Okay, in the absence of any question.
Just hold on, Fred. Just hold on there.
Okay.
In 2015, you gave us a WinPepi, and now we want to use WinPepi for Sunday. Are you giving us a new version?
You said 2015.
Yes, in Bayelsa, you give us WinPepi.
Yes, that's true.
You gave us WinPepi in Bayelsa. Yes, and that's the one we want to use on Sunday.
What will happen? Yes, what I was no, you can actually download though. Even the WinPepi, if you go to.
Is it free? Is it free?
It's free now.
WinPepi is free.
It's free. The man said that did he just die not quite long? Is it 2017 that he died? He's giving free. One prof like this that did it, that invented it, and it's free. So if you want to, even if you click on the something, there's a place where you can click on the new version. I was trying to download the new version. I think version 2017. I mean, the thing just got aborted. I will have downloaded it. So you can actually download it. You can even Google WinPepi. It may take you to where you can get it. Or the one you have, if you click, there's a place. If you click, there's a place you can click on. You look for a place, you click on information where you can get information. You click, it can take you to, if you're online, if you're connected, it will just take you to the site where you can download the latest version. So I will encourage everybody to do that. Download instead of sending it through Google Drive. So you can use something that is free. Just like a trigonometric calculator. WSU anthropometric calculator, you get to the site and download it on your computer.
Okay, thank you.
Okay, welcome, sir. So, any other one? So, okay, let me just, if that's okay, let me just pause the recording now so that